Hello everyone, welcome to Bio Tutorials. In this video, we're going to solve problem from the book of Yunus A. Central and John Simbala, Chapter 6, Fluid Flow Measurement. Firefighters are holding a nozzle at the end of a hose while trying to extinguish a fire. If the nozzle exit diameter is 8 cm and the water flow rate is 12 cubic meter per minute, determine the average water exit velocity and the horizontal resistance force required of the firefighters to hold the nozzle. Firemen are holding a nozzle at the end of the hose while trying to extinguish a fire. The average water outlet and velocity and the resistance force required of the firemen to hold the nozzle are to be determined. So we need to assume that the flow is steady and incompressible. The water jet is exposed to the atmosphere and thus the pressure of the water jet is the atmospheric pressure, which is disregarded since it acts on all surfaces. Gravitational effects and vertical forces are disregarded since the horizontal resistance force is to be determined. And the jet flow is nearly uniform, and thus the momentum flux correction factor can be taken to be unity. So we need to take first the density of water to be 1000 kg per cubic meter, and also we have the given diameter of 8 cm and the volume of 12 cubic meter per minute. We take the nozzle on the horizontal portion of the hose as the system such that water enters the control volume vertically and outlets horizontally. This way, the pressure force and the momentum flux at the inlet are in the vertical direction with no contribution to the force balance in the horizontal direction. And designate the entrance by 1 and the outlet by 2. We also designate the horizontal coordinate by x with the direction of flow as being the positive direction. The average outlet velocity and the mass flow rate of water are determined from velocity is equal to volume over the area such that volume over pi d squared over 4, and by plugging the given values, we had volume of 12 cubic meter per minute and pi, the diameter of 0.08 meter or 8 centimeter. We just need to convert it into meter square over 4. By using our calculator, we get 2387 meter per minute, and by converting it into meter per second, we get 39.79. We just have to divide this by 60 in order to arrive at 39.79 meter per second or 39.8 meter per second. So we have the mass density multiplied by the volume. We have the given density of water, which is 1000 kg per cubic meter, multiplied by the volume, which is 12 cubic meter per minute, and we get 12,000 kg per minute. And by converting it into kilogram per second, we just need to divide this by 60, and we get 200 kg per second. So next, we need to determine the horizontal resistance force required of the firefighters to hold the nozzle. We need to assume and relate the horizontal force applied by the firemen to the nozzle to hold it to be resultant force along the x-axis and assume it to be in the positive x direction. Then the momentum equation along the x direction gives Fr along the x-axis is equal to mass multiplied by the exit velocity. Since we need to substitute all the given values that we already solved, we have 200 kg per second multiplied by 39.79 meter per second. Since kilogram per second times meter per second is equivalent to 1 Newton, since we were looking for the force, we need to convert it into Newton. 1 Newton is over 1 kilogram multiplied by meter per square second, and by plugging it into our calculator, we get 7,958 Newton. So therefore, the firemen must be able to resist the force of 7,958 Newton to hold the nozzle in place. The force of 7,958 Newton is equivalent to the weight of about 810 kilogram. That is, holding the nozzle requires the strength of holding a weight of 810 kilogram, which cannot be done by a single person, and this demonstrates why several firemen are used to hold a hose with a high flow rate